Hello everyone. I'm going to talk about angle chasing. I'm going to talk about angle chasing using a problem from the IMO Shortlist 2023. I'm going to talk about angle chasing because most angle chasing solutions proceed in one of two directions in the finished solution that you are reading. The first direction it goes in is just by angle chasing, comma, we find blah, and you're just kind of expected to know it. It's just like, oh, this is boring, this is just too much work, why, I don't think anyone needs to see the details, so therefore by angle chasing we find this. That's really annoying because, speaking from experience, I've not always been successful in reproducing the angle chasing mentioned by some of the problem proposers and their solutions. Now, the second thing that happens is just a very, very, very long list of this equals to this, 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 with no intuition whatsoever. And so it's just like, this is boring, or this is, why would you specifically check for this angle? Why you specifically check for that angle? That's also pretty annoying. And so either it's one line or just 3 paragraphs of meaningless stuff. Now, depending on what competition you are taking it in, you may be allowed to write the first line if it's simple enough. You may also be allowed to just write the second one because whoever's reading your solution already knows how to solve it. So they don't mind if you wrote a lot of steps and don't really explain the intuition behind them. But I don't think that's very good for learning and for understanding. And so in this video, I'm going to look at this problem from the IMO Shortlist, and we are just going to talk about how to do angle chasing. Now, the first thing about how to do angle chasing is, let's draw a diagram. So ABC is a triangle. If AC is greater than BC, omega is the circumcircle, R is the circumradius. I'm going to approximate how this would normally look like if we were to just draw a diagram freehand. It may look something like this. Got C here. This is the circumcircle omega, R is the circumradius, P is chosen on AC such that BC equals to CP. S is the foot of perpendicular from P to AB. Ray BP hits omega again at D. Q is chosen on line SP such that PQ equals to R, and SPQ lie on a line in that order. So this extends out by roughly something that makes PQ look like the radius. So I think somewhere about that maybe, oops, I called R, I meant Q. So PQ is R, where R is the radius, and then E is a point satisfying AE is perpendicular to CQ. And BE is perpendicular to DQ. And then you're like, oh, prove that E lies on omega. So actually I should probably adjust it a little to make it look like it goes through the circle. And as I'm doing this, some of you are getting ready to just stop the video because this is just way too dense and confusing to look at. Now, what I'm going to say is, the first thing about angle chasing is that some of us are really bad at staring at a diagram like this and knowing what to do. So just scratch that. Well, not literally, please don't cross out your diagram, you took some effort to do it, but don't expect that you'll be able to make anything from such a confusing looking diagram under normal circumstances. Now, what you should be doing, the first tip is to just do things in a gradual fashion, unless you can draw a really nice diagram. Now, I have prepared what I think is a nice diagram. which is of course digitally made. This could be a nice diagram. Now, I'm not going to use it for this problem. You can use a nice diagram if you like. I am not going to use this, and I'm also not going to use that. And so this is normally the experience we have. Let's throw that away. I'm going to have a split screen first so that we can look at the question while also looking at the workings. So let me adjust things a little bit in Microsoft Word. Okay, so we can now mostly see the problem, but I think you don't need to see the fact that it's from the IMO Shortlist, so I'll give myself a bit more space at the bottom. And what we will do is to do it step by step. So we have drawn the whole diagram, but what you should be really doing very often is just getting to know each of your points better. Now, what I mean by this is that, for example, if you were to be a Marvel fan and you're looking at the Avengers did not come as the first Marvel movie. The Avengers comes after all the individual characters are introduced, and therefore you get to know them individually before you all put them together and sort of they unleash their special powers and abilities. And that's what we like to view a geometry question as. I'll still draw a circle. I will cheat a little with technology to make sure the circle looks nice. And then I am going to just put in ABC. ABC are fixed. So ABC are not going to vary. ABC are just the so-called skeletal features of my diagram. Now, ABC are the skeletal features of my diagram, so I am not too concerned about any unique features of ABC. The only thing they told me is AC is greater than BC, and I drew that thing just now. I know that's important because of BC equals to CP. So we put that there first, and then I'm going to sort of put in P. So P is the first point. Now, I'm straight away going to pause and say, okay, if BC is equal to CP, what is interesting about the fact that BC and CP are equal? And so my conclusion is that, well, not that much, but I would know all the angles involving P, right? Because this is angle C, this is 90 minus C over 2, this is 90 minus C over 2, this is A, this is 90 minus C over 2 minus A. Basically, I can find everything. Now, I'm going to erase this for now, but I just want to remember that I could find them. Right, so can find angles relating P to ABC. And I'll erase this just knowing that I can find them later. Now, the next guy that is introduced is S. So, hello to point S. S, you are the foot of the perpendicular from P to AB, and then you are kind of never really mentioned again in a useful way. Right, so S is just a supporting character that really I don't care so much about. I just want the perpendicular line from P to AB. So S is mostly irrelevant. Sorry, S, we are going to ignore you. We are, however, going to draw the perpendicular line. Now, the perpendicular line from P to AB is more important for us to be able to get point Q, which we will deal with a little bit later. Now, next thing is that BP meets omega again at D. Now, that's just an extension. And the question is, what can I do with D? Well, I do know that there are going to be equal angles And in fact, this is also going to be isosceles. Now this brings in the next thing that I want to say about angle chasing, which is use a little bit of color to help yourself. I say this in all my classes, I say this in some of my round 1 videos, and I will say it again here. Right? Use some color to take note of things that are equal. That's often enough. You can mark out the angles and the lengths. I'm not going to mark everything out because otherwise there's just too much things happening. Next up is Q. Now Q is supposed to be somewhere where PQ is equal to R the radius. So it's also supposed to be on the opposite side of our ignored point S. So I'm going to put Q somewhere around here. I think that looks reasonable. It's probably a bit closer to the circumference, but I need to see something. So Q is there. And I'm going to pause again and say, okay, what is the use of PQ being equal to the circumradius? Now, I believe that with A, B, C, D on the circle, there are already 4 lengths which are equal to R, literally OA, OB, OC, OD, where O is at the center of the circle. Now, I would like to mark out the center O, and I would like to ask myself, what is the most useful one to connect it to? Do not connect it to all of them A, B, C, D immediately. So what's the most useful thing to connect it to? And in order to do that, I would like to look at the angles that are around the line PQ. Now remember our guy S that has disappeared, it was important that this is the right angle. So to understand how to make use of this length, I know that this is 90 degrees minus A. Where else in a circle am I going to get 90 degrees minus A next to the radius? Well, that would be if you connect it to the center of the circle. Let me draw a straighter line. If you connect it to the center of the circle, this is 2A. And so this would be 90 minus A and 90 minus A. So I've learned that, oh, actually, if I draw this in here, color being deliberate again, those are congruent triangles. I didn't know CQ is equal, but I already have got SAS. So this is, Q is actually the point such that triangle COB is congruent to CQP. That's what makes Q Q. And of course, once I have this, I know all the features of point Q, including that this angle is also 2A, this angle is also 90 minus A. I am going to once again erase most of those for now because there's too much going on. But we know we can find them. Just like I can find stuff to do with P, now I can find some stuff to do with Q. Now the next thing is E is a point such that these two are true. Show that E lies on a circle. It's quite clumsy from a drawing perspective. If I were to draw 2 right angles and keep reminding myself that I don't know yet that E lies on the circle. But essentially this is saying that I want to show 2 lines, the perpendicular lines, and the circle are concurrent. And so I'm going to redefine it where E is actually going to be on omega and on one of the perpendicular lines. So I'll use AE is perpendicular to CQ because I know something about CQ, I don't yet know anything about DQ. So I want to show that BE is perpendicular to DQ instead. So I redefine it, and that would also be easier to draw. I would like to also say that perpendicular lines are something where you can use the feature without always drawing the lines until they intersect. For example here, right? So I want E to be such that AE is perpendicular to CQ, something like this. Now, I do not, however, actually need to keep that in my diagram as long as I know that these angles sum to 90 degrees. Specifically, QAC and QCA should sum, not Q, this point AC and this point CA, which I do not want to leave in the diagram. In other words, AE being perpendicular to CQ should just imply that angle QCA plus angle CAE equals to 90 degrees. And that's a more useful way to put it, because it means that angle EAC is, well, this was 90 minus A the whole time, so angle EAC is A. In the original triangle. See, I still haven't finished drawing the diagram, but that's okay. Because angle EAC is angle A, means that I have found that these two are both angle A. Now, if these are both angle A, it jumps straight to the fact that these are angles at the circumference of a circle. So don't need to draw every single thing in. Just know that if they are angles at the circumference which are equal, it means that these are equal arcs. And equal arcs means they are symmetric, both in terms of equal arcs as well as equal line segments, which allows me to draw one more thing that is also equal to all the rest, right? Because if CE is the same as BC, it's also red. So I can color it here. Oh my gosh, Microsoft Word is being too smart. It drew a box. Okay, there we go. BC equals to CE. I'll erase that. So now these 3 red lines are equal, those 4 green lines are equal, those 2 yellow lines are equal as well. The thing that I haven't talked much about is D. So I've looked at P, I've looked at Q, I've now learned what makes E, E. I need to know what makes D, D. And to figure out what makes D, D, it's a bit hard because now D has quite a lot of angles that I may potentially be interested in. However, the most simple one is just that this is still the same as that, which is angle C. So that's the location of D on the circle is sort of known. Now I would like to suggest that we take that arc understanding a little bit further, however, and sort of say that I can label all their relative positions on each other by labeling each arc. Now this arc AB, its measure is 2 angle C. This arc here is 2 angle A, and the rest of it is 2B. But I can further say that I know that this portion here is also 2A because BC equals to CE. And so the entire circle's arc should add to 360 degrees, which is 2A plus 2B plus 2C. So this was 2B, this is 2A, Now this would have been 2b minus 2a. Now, I'm doing this also because I want to know where they are relative to each other and I don't want to clutter my diagram. Now remember, at the start we already said that I can find all the angles relating P to ABC. Now that means that I can also get the arc AD, which is angle PBA. PBA, which we probably had written at some point just now, is B minus angle CBP, which is B minus CBP is 90 minus C over 2, which is B plus C over 2 minus 90, and 90 is actually A over 2 plus B over 2 plus C over 2. So this would be B over 2 minus A over 2, and so the arc would be just B minus A. I'm raising this off because I'm trying to keep everything in the screen to show you how I would do angle tracing in a diagram. So this arc is B minus A. Now that was 2B minus 2A, and so therefore this part is also B minus A, which means that also this is equal to those two. So that's nice. More equal stuff. So I've now figured out where are A, B, C, D, E on the circle. I've now figured out that Q is just the point where I got this congruent triangle down there. Now it's time to prove what I want, which is BE is perpendicular to DQ. I would like to show another perspective on our angles, which is just that we can think of this as rotation. Now we can think of this as rotation because AE and BE share a point E. CQ and DQ share a point Q. Now, if they were perpendicular at first and I want them to be perpendicular at the end, all I need to show is that the angles that are rotating AE to BE and CQ to DQ are the same. And of course, the angle of rotation is just literally an angle, AEB. Is how much you take to rotate from AE to BE clockwise, and to rotate from CQ to DQ, this is going to be CQD would be counterclockwise, right? The other way. So it actually should be 180 minus CQD. And of course AEB is just angle C. This angle AEB is the angles, this is 2C, ACB is C, this is C, and so I just need CQD to be 180 minus C. And at this point, I think I don't really need the question anymore, so I am going to remove this split so that I have more space to write. So we don't need the question anymore. I can now say CQD is 180 minus C and ask myself, okay, how would that happen? Now, how that would happen, I might say, do I have any place in the diagram where there is going to be a 180 degrees minus C? The answer is not really, because this is C, which means 180 minus C would have been somewhere down here, but that's not very useful. So I don't want to have that, but I do know that I'm going to have two things that were 90 minus C over 2, which is half of that. So I'm going to explore this further, right? I know that the one closest to it is CPB is 90 minus C over 2. I have 180 minus C. This is twice of that. There should be something interesting since they are so near to each other. Until I realized that, oh yeah, I can actually sort of take their supplementary angles. CPD is 90 plus C over 2, and for CQD, I can actually say that the reflex angle is 180 plus C. Now this is twice of that as well. CQD is supposed to be twice of CPD when I already know that CQ equals to QP, and this is twice of that. Actually, I just need to show that Q, there's one more green line here. Q is the circumcenter of CPD. In other words, if that were the case, then the reflex angle CQD would be twice of CPD, which is what we want. Now, in order to get that Q is the circumcenter of CPD, I now know where everything is. So I should be able to just use the angle at the center is twice of the angle of the circumference of something else, which hopefully is not the CQD itself. That's great then, because I have marked down here, I know what CQP is. Well, I know that because even though I have not written it down, I don't remember why this is still marked with a single angle here. I can still see that it's sitting inside the isosceles triangle that's congruent to the original isosceles triangle. And that's where the color comes in, right? We sort of know which are the parts of the diagram where we have more information and we are comfortable going back there. So angle CQP is angle COB, which is 2A. And I would like it to be twice of CDB, which it is. CDB is CDP as well, and so CQP is twice of CDP, means that D also lies on the circle centered at Q, passing through P and C. And we are done. Now what I've tried to do here is to break down the intuition behind the angle chasing, but at the end of this you realize that a lot of the things that we wrote in color have not been written in words. We need to translate it into words, and therefore your final solution is still going to look like a whole bunch of workings of just this equals to this equals to 180 minus this equals to this equals to this. In fact, I didn't even use the fact that these three yellow lengths are equal to each other at all. That was just a discovery that turned out to be irrelevant, but fine. Because I knew that I was aware of the locations of all the points relative to each other on the circle, that means that in some sense, I have no missing information, and that's why I had the confidence to just proceed. I know that I have subsumed all the information into a statement about where is it on the circle. I don't need to revisit existing information. Now, the ideas again that we said from the start. Number one would be focus on each point one at a time before looking at the whole diagram. Take note of what is the characteristic feature of each new point that you introduce. Two, use color in order for you to quickly recognize when things are equal, because after a while, if you use 1 mark, 2 mark, 3 mark, 4 mark angles or lengths, it's very hard to see anything. 3, our angle chasing doesn't always have to involve only angle sum in a triangle, angle sum on a straight line, vertically opposite angles. We can be a bit more sophisticated, right? For example, when I used the perpendicular without drawing them to intersect, or when I used a rotation in order to relate two conditions instead of literally just adding and subtracting angles over and over again. And the last thing is that every time I see an angle, I ask myself, have I seen that angle before? Whether it was 90 minus A, whether it was 180 minus C. You just ask yourself, have I seen this angle somewhere else? Rather than literally angle chasing the whole diagram full of angles to the point where you cannot see anything at all. I hope this helps. I hope this also gives you some inspiration that, you know what, IMO shortlist questions are not hopelessly hard. They are only just hard if we don't know how to compartmentalize all of our information well. Thanks for watching, and I'll be back soon with the rest of the solutions for the ongoing SMO Open paper.